Optimization with quadratics. The process of finding a max or min is often called optimization. So that's all it means. When they want you to optimize something, that means to find the max or min. And when we have quadratics, the way you find the max and min is just by finding the vertex. Remember, the way we find the vertex is by using the formula x equals negative b over 2a to find the x in the vertex. That is not the max or min, that's where the max or min occurs. And then you plug it in. To find the max or min. Remember, if your a is positive, right, we have a general quadratic right here. When the a is positive, it's a minimum, because your graph opens up. So we're going to have a minimum, and it occurs at the axis of symmetry, negative b over 2a. You plug it back in to find the max. Trying to find the min. When a is less than 1, when a is negative, it's a maximum, so it opens down. The same thing occurs. So let's do a couple quick examples. Find the max or min value of the following quadratics and the corresponding value of x. So here's our first one. We want to find max. Literally, all we can do is find the vertex. That's all we have to do. So x equals negative b over 2a, and of course, it's going to be kind of disgusting. So I get negative 1/2. So that's where my max occurs, at negative 1/2. We're going to substitute back in to find the actual max. So y equals negative 1/2 squared plus 1/2, negative 1/2, minus 3. So this is going to give me 1/4 plus negative 1/2 minus 3. Just for the sake of it, I'll just do it all by hand real quick. I'm going to put this over 1. We want a common denominator over 4. So let's multiply this by 4 over 4, 4 over 4, 2 over 2. So I get 1/4, negative 2/4, minus 12/4. Negative 14 to 1 minus negative 14 is 13 over 4. So there is my max or min. My vertex is negative 1/2 and negative 13 over 4. This is a positive a, so it opens up, so we have a minimum. So this is our minimum. Is negative 13 over 4. Is our minimum value. Okay, next one. So I'm going to rearrange it first. So I get this. Now notice in this one my a is negative, so it's up and down. So we're going to have a maximum value this time. Use the formula again. X equals negative b over 2a. So negative 3 over 2 times negative 2. And of course, does it hate me? This is all the fractions. So 3/4. So again, that's where my maximum occurs. It occurs at x equals 3/4. If you want to find the y value, the actual max, we're going to plug it back in. So negative 2 times 3/4 squared plus 3 times 3/4 plus 3. So I get 9 over 16 times by negative 2. So I can reduce this and get 9 over 8, negative 9 over 8, plus 12 over 1 over 4 plus 3. Again, just for the sake of it, let's do it by hand. So I'm on the common denominator, so multiply this by 8 over 8 and 2 over 2. So I'm going to get negative 9 over 8 plus 24 over 8 plus 24 over 8. And I'm going to get... I did that wrong, right? There's a little mistake there. This should be 9. This should be 18 over 8. So 18. So these two give me 9. 9 plus 24 is 30 over 8. So there's my maximum. My max is at 30. My max is 33 over 8. So something like that. I don't know why the book made all the all the practice questions disgustingly horrible problems, but that's the process is easy. You just find the vertex. Use axis symmetry formula, negative b over 2a, to plug in and substitute the proper values. Once you get that value, that's where the max or min occurs. Plug it into the equation to get the y value. And you get the max. Okay, let's do an application problem. A gardener has 60 meters of fencing to enclose a rectangular garden plot, where one side is an existing brick wall. Suppose the two new equal sides are x meters long. So here's our brick wall. They're saying these two sides are both x. Show that the area enclosed is given by this. So we want to show the area enclosed given by this, and then we want to find the max garden. Now the area enclosed, keep in mind we have 40 meters of fencing. So this plus this is 40. Well, I know these two sides are x, so it's kind of like what we did before with the wire. I'm going to do 40. To figure out what this side is, it's 40 minus x minus x. So it's 40 minus 2x. Goes right there. So that's that side of fencing. If I want area, area is its length times width. So my area is going to be x times 40 minus 2x. So like that. Distribute. I get 40x minus 2x squared is my area. I guess I should have stopped right here because that's what they're talking about right there. Okay, so there you go. There's A right there. Find dimensions to give the max area. So I just want to find the max area of this. Now if you notice this, it is a negative A squared, so it is up and down, so we do have a max. And then how do I find the max of anything? Just find the vertex. So use max of symmetry, negative B over 2A. Now, again, it's not written the proper way, but this is my A, because it's the x squared, and this is my B. So I'm going to get negative 40 over 2 times a negative 2. So I'm going to get negative 40 over negative 4, which is 10. So x equals 10. 10, not 0. So again, that's what my x is. That's the length of this guy. This is 10, and that's 10. So you plug it in. 10, this makes this side 40 minus 10, which is 20. The question wasn't, oh, I guess the question was find the dimension. So the dimensions that give max area are 20 by 10. Or you could say 20 width and 10, or 20 length and 10 width. I thought the question was the max area. If that was a question, I want to find the area, so it would be 10 times 20, which is 200. But they just wanted the dimension, so 20 meters times 10 meters. Give me the max area dimensions. Okay, let's do one more. The graph of y equals x squared minus 3x equals and y equals 2x minus x squared are illustrated. Show the graphs to me at where x equals 0 and x equals 2.5. There they go again with the decimals. So that's what I show where like these two things match, which is right here and right here. Well, you show where they intersect by setting equal each other. So let's do that. X squared minus 3x equals 2x minus x squared. So like that. We're going to move everything to one side. That's how you solve a quadratic. So subtract 2x, add x squared. I'm going to get 2x squared minus 5x equals 0. Luckily this is easy enough to solve. Right, you set the factor of them in common, which is an x. And I get 2x minus 5 equals 0. Split it, x equals 0 and 5 halves. So there we go. So I showed that they meet f 0 and 5 halves. Find the max vertical separation between the curves from there to there. So they want to find where this guy is a maximum. And one way to find a max is just find this equation, this line, and find the max. Like if it's quadratic, we're going to find the vertex. So how do you find the equation of this line? Well, it's just this red line minus this green line. That's what gives you this one. So the red one is 2x minus x squared minus the green line, right? Top minus bottom, which would be x squared minus 3x. So try to find that equation. Distribute the negative. So I'm going to get 2x minus x squared plus 3x. That gets me negative 2x squared plus 5x. I'm trying to find the max of this guy, so we're going to use the formula. X equals negative b over 2a. So here, to find the vertex, here's my a, here's my b, so I get negative 5 over 2 times negative 2. 5 over 4 is where it happens at. So they're saying that 5 over 4 is where my max is at. I want the max separation though, so I got to substitute that back into my equation. So I get y equals negative 2 times 5/4 squared plus 5/4. 5 times 5/4. I mean, again, we could use our calculator for this. I've been doing it by hand just to kind of practice, but feel free to use a calculator. So let's simplify this by hand one last time. But again, you could feel free to use a calculator. This should be 16 plus 25, or this is always over 1, over 4. If I want to do this by hand, this is practice. Multiplies by 4 over 4 to get a common denominator. This multiplies in there, I get negative 50 over 16 plus 100 over 16. So I get 50 over 16 is a max separation. And that's the lesson.